In this video, we'll be looking at queues. Queues is also another example of ADT, abstract data types. It's a bit different from stacks, which we covered in our previous videos. So let's start with the concept of queues. So this is our queue. These are its index positions. In Python, we're going to take it as an array. So queue follows the principle of FIFO, first in, first out. So when data is added, A, B, C, D, E, the first to be removed will be A, because this was added first, then B, C, D, E. So in stack, we had a stack pointer, but in queues, we have a head pointer and a tail pointer. This is so that one will be used to add the items and one will be used to delete the items. So in stack we had push and pop. In queue we have enqueue, which is adding an item, and dequeue, which is removing an item. So let's start. Our head pointer points towards -1 and our tail pointer points towards 0. So the tail pointer is used to add values while the head pointer is used to remove values. So now if I want to add a value, I'm going to add A here, and my tail pointer will move forward. Then I'll add B, is going to move forward. So it's going to be pointing at the free space, the next free space. So when I'll add A, then it'll move one step forward, then B, then forward, then C, then forward. The tail pointer, however, points at the first item in the list. So if my tail pointer is pointing at -1 and I've added an item, it will point towards 0. However, it's going to stay here because it always needs to point to the first element in the list. So now that I've added 5 values, my tail pointer points here, but my head pointer is still here. But now when I remove values, I will first remove A. So I will first remove the value where the head pointer is pointing toward. So I will remove A. And once I've removed A, my head pointer will move to the next first item in the list. Now there are two different types of queues. We have linear queue and circular queue. So this here is a linear queue. When I have B, C, D, and E, I cannot add another value in this queue. Even though I have a free space here, I cannot add another value because my tail pointer is out of bounds. But in a circular queue, my tail pointer will go back towards the start and then add values in free spaces. So now let's write its code. Let's start with linear queue and queue. So first we're going to take an array. Let's take a 5 element array. Then we're going to initialize our head pointer to -1 and our tail pointer to 0. Now we'll write the function enqueue. This takes the data as a parameter, the data we want to add in the queue. And I'm going to take my array, the head pointer and tail pointer as global. So the first thing to do is see if there is space in the array. So if tail pointer is less than 5, so this here means that if the tail pointer is pointing to any of these positions, if it's not at 5. If it's less than 5, then I can add the data, and then I can increment the tail pointer, and then I'm going to check that once I've added the data, if this is the first value that I'm adding, if it's the first value, then I need my head pointer to go from -1 to 0. So for that, I'm going to check if my head pointer is pointing to -1, I'm going to move it to 0. However, if the tail pointer is greater than 5, then I'm going to print queue is full. So let's try running this code. Originally, this is going to be my array, an empty array. So let's see. First, it's empty. Then when I've added 2 elements, I'll have A and B. So when I've added all 5 elements, it'll have A to E. And if I add another element, it will give me queue is full. So this is how adding an element in a linear queue works. Now let's write the code for linear dequeue. So for that, I need to check if there are any elements in the queue, because if it's empty, that means that there is nothing to remove. So first, let's take these 3 as global. Then let's check if head pointer is equals to -1. We're going to print queue is empty. Else, what we're going to do is remove the value where the head pointer is pointing towards, and then increment the head pointer so it will point towards the next first value in the array. So like once this has been removed, this will point here. Once this has been removed, this will point here. So that is how this works. So let's try running this. So after adding 5 elements, let's remove one element. Here you can see that our A from the start, A is at the start, so it's been removed. Here we have ABC removed. And here we have all of them removed. And if I remove it one more time, I'm gonna list assignment index out of range. Why is this giving me an error? It's giving me an error because I forgot to add one condition. This is if head pointer is equals to tail pointer, then we're gonna reset it. I'm gonna take my tail pointer back to 0 and my head pointer back to -1. This means that once all of the elements have been removed, now it's at E. So once E has been removed, head pointer and tail pointer will be at the same position. So once the queue is empty, I'm going to take head pointer back to -1 and tail pointer back to 0 again. So now let's run this. Now it's going to give me queue is empty. So now let's look at circular queues. So the difference in linear and circular queues is, as I've discussed here, that once the elements have been added, so if I have A, B, C, D, E, my tail pointer is pointing here, and my head pointer is pointing here. So if A has been removed, so then my head pointer will move here, but I want my tail pointer to come back here so I can add any new element I want. So let's start. First, let's write the code for adding an element. Let's use the same array we made. Let's take these as global. Now, to check if our queue is full or not, we need to take a new variable, number of items. So initially, my number of items will be 0. So here in this case, you can see that if my number of items are equal to 5, that means the queue is full. But if it's less than 5, that means I can add another element. So here I would need to take global number of items as well. So first I'm going to check if number of items is greater than or equal to 5. I will print queue is full, else I'm going to add the data to the value. Then I'm going to check if my tail pointer is greater than or equal to 4, meaning if it's exceeded the last line, if it's outside of this range. So if it's greater than or equal to 4, because I have it 5 elements, so it goes from 0 to 4, then I'm going to reset my tail pointer to 0, and if it's not, I'm going to increment it by 1. And after this, I'm going to increase the number of items. So this is how it's going to work. Let's try running this. Let's remove all of this. Let's see if this works. Yes, we have A. Let's add 5 elements first. So let's see. Here we've gotten our 5 elements. So now to understand this even better, to see that if we remove an element, will it add a new one here? We need to write the code for circular dequeue. So for that, right, let's define our function. Let's take all of these as global. first we're going to check if the queue is empty or not. So we'll do that by checking if the number of items is equal to 0. Then we're going to print queue is empty. Else we're going to assign it an empty string. And then we're going to increase the value. Oh, sorry, this is supposed to be head pointer. And then we're going to increase the value of the head pointer. Then we need to reset the head pointer as well. So if our head pointer is pointing here, then I need it to go back to the first position. So for that, I'm going to add the condition if head pointer is equal to, sorry, if head pointer is greater than 4, then I need it to go to 0. Then I'm going to increase the number of items. So this is how my dequeue is going to work. Now let's try it. Oh, why is it removing the last item? I apologize. I made a small mistake in circular enqueue, just like I made the mistake here. I forgot to add this condition. So I need to add this condition so that my head pointer will be updated. Hopefully it's going to work now. Yeah, it works. So let's try this again. We have A, B, C, D, and we dequeued one item. So A has been dequeued. Let's remove 3 more items. So we have these 3 removed. Now I want to add another item. New. So here our new will be added here. So I want to add another item. So here we have our new items. So this is how a queue and a circular queue works. I hope you understood the concept.